first question starts off, and my guess is that people were fairly confused right away.
Yeah.
Let's think about the slope field that's given. Notice the slope field says it's y squared times 4 minus y squared. So one thing I'm going to notice in this situation is that if y is equal to 0, then the slope is 0, correct? So I notice that along any point here, I also have a slope of 0, okay? So what it's saying is this. G of x is the solution. And we know that the solution to a differential equation, the solution is the graph, right? And it goes through what point? -2, -1. So I'm going to plot -2, -1 approximately, right about there. Everybody good with that? So if you were going to draw a solution that goes through that spot, okay, as x goes towards infinity, I'm going to say that your graph is going to go something like that. Everybody see how I drew the graph through that spot? Everybody see why I tapered off that way? So now they're asking, so look at, they've kind of combined three elements. Number one, you have to know that the graph is the solution. Second of all, you have to be able to plot the point and then draw the graph. And then third of all, you have to apply what the meaning of a limit is. What is this limit as x goes to infinity? What's the y value approaching? 0.
Yes.
Folks, so at this point, like, I can't see what's happening in your brain, okay? That's not a problem we practiced, right? So my question to you is, does that kind of make sense now? Do you get why I chose this point, -2, -1? Okay? Do you see how the slope is trending this way, and then it slows out as it heads towards 0?
Yeah, but like, why don't you go above the x-axis and like follow it?
Because it's flattening out there. The slope is 0. So if I pass through, my slope wouldn't be 0. So if I went like this, well, I just passed through a 0 slope, but yet my graph doesn't have a slope of 0. Get my point? This is telling you you've got to flatten out. Better? Good question. All right. F double prime of x is given to you. It's asking about concavity. A graph is concave up when what? When f double prime is greater than 0, you're concave up. If you don't remember that, you have 0 shot at the problem other than guessing. So that's my first question is, do you know that concave up is f double prime greater than 0? That's something you're going to have to commit to memory. We've talked about it. You're going to have to make a note. That's something I've always wanted to do, is put together like a master list of notes that you look from. And I've tried and tried and tried. I can't come up with a good one. So I don't know. I actually thought about like making it like an assignment for you guys, or maybe I could say you get to use notes on your test this year, and we use those notes to compile something together. Okay, I don't know what to do. All right, so there's two ways to do this. I'll show you the way I did it, and I don't know if you like that way, but I want feedback from you because, again, I don't know what's happening for you. If I look at this graph, I can see it's a cubic and has a double root at -2, and it has another solution at 0. And I can see that it has a double root there and then there. So therefore, where is it above the x-axis? From 0 to infinity. Now, here's the other way to do the problem. You have x times x plus 2 quantity squared. I told you you could test points, so -2 and 0. So try -3. -3 times -1 squared. Is that going to be positive or negative? Negative. I'll try a number between -2 and 0. I'll try -1. You get -1 times 1 squared. Is that going to be positive or negative? Negative. And I'm going to try a number that way. I'll try 1. 1 times 3 squared is going to be positive. So I don't care whether you look at the graph or whether you test points, you have to realize that it's positive from 0 to infinity. So does the graph make sense to you or not? Do you remember that a double root is going to have that behavior? Okay, so that's part of, if you can't see that, then you've got to go to the number line test. Do you get my point? So I don't know what your resources are at that point. If you don't know the graph, then you got to go there. Just quick show of hands. Who remembers that the graph looks like that? Because we're about a fourth. Got it. All right. All right. This one is asking for the derivative at x. Oh. So x greater than 0. Yep, B. All right. Sine of x times cosine of x. You want to find the derivative. What rule do I have to use to find this derivative? Product rule. What's the derivative of sine? Cosine of x. So you got cosine squared of x. We multiply them together. And then what's the derivative of cosine? So you get minus sine squared. So that's the derivative. It's asking for the derivative at pi over 3. So now you got to plug in pi over 3. Does anybody know what the cosine of pi over 3 is? 60 degrees. So that coordinate is 1/2 root of 3 over 2. You're going to have at least one, if not two problems on the test where you have to come up with a terminal point. If you don't know how to come up with a terminal point, they're going to be guessing, and it's going to be a tough deal. But hopefully you know how to come up with those. We've done a pretty good job of going over them. Cosine is the x value or the y value? Cosine is the x. So I got 1/2 squared minus the root of 3 over 2 squared. So I get 1/4 minus 3/4, and that is negative 1/2. Okay, limit as x goes to negative 3. If you plug in negative 3, what do you get? You get 0 over 0. So that means you got two options. You can either remove the discontinuity by factoring, or you can use L'Hopital's rule. Anybody use L'Hopital's rule? Okay, good for you. So L'Hopital's rule says you take the derivative of the top, which is 2x, and the derivative of the bottom, which is 2x minus 2. Now when you plug in negative 3, you get negative 6 over negative 8. So the other way to do it is to simply factor x plus 3 times x minus 3. And on the bottom, we've got x minus 5 times x plus 3. Notice how those cancel. If you plug in the negative 3, you get negative 6 over negative 8. It is positive 3/4. Hi.
So why can't you do that thing where when they're the same power, it's just the first, like to figure out the coefficient?
Because there's no coefficient.
Yes, there is.
Excellent question. That only works when you're approaching infinity. Only works when you're approaching infinity. Nope. Got to be approaching infinity. It's the, remember it's this deal. Remember when you factored out, you would factor out the x squared and you get 1 minus 9 over x squared? Remember when we do that? The deal is that you're plugging in infinity. That's why that goes to 0. So that's the context that you're sitting in. So if you see infinity there, then you can do that. Then you would just say it's 1. Like if I saw infinity, I'd be like 1, done. But it's not infinity. But good idea. Thanks for bringing that up. Now we see that. Okay, what's the average rate of change? Average rate of change is not derivative. Average rate of change is slope. That's all it is. Slope. So I'm going to plug in pi over 2 here. 2 times pi over 2 is pi. What's cosine of pi? Negative 1. Minus, now I plug in 0. What's cosine of 0? 1. Divided by pi over 2 minus 0. I get negative 2 over pi over 2. Multiplied by the reciprocal, I get negative 4 over pi. A. So, the key to the problem is this, that you recognize in this situation that the average rate of change is slope. That wasn't happening. I get it. Can we lock that one in? Okay. Average rate of change is slope. Period. You can sure try. Thank you. Effort means everything. All right, next one. I hope everybody got this one right. We find the derivative with respect to y of x. Okay. So we've got 3y squared y prime plus y prime is equal to 2x. We solve for y prime by factoring it out. We get y prime times 3y squared plus 1 is equal to 2x. Divide by the 3y squared plus 1, and we get this guy right there.
So y prime
Okay, so folks, when it comes to the AP exam, all three of these are the same. Okay, f prime of x, y prime, dy over dx, they mean the same thing. Why do they write dy over dx? Because this is not a function. You can't use function notation. So they could say find y prime, they use dy over dx. That means in this situation you use implicit differentiation, okay, where you attach the y primes every time. That should be recall where you're like, oh yeah, I remember that pretty well. Maybe you didn't get right, but we did do a bunch of problems on that one time, right? Okay, good. Flip it over. Gonna have for sure, promise, at least a couple questions on this on your test. Looking at graphs, interpreting the derivative or the function. Do they give you the derivative or the function? They give us the function, and they say which of the following could be the graph of f prime. So I'm noticing that from here to here, the derivative is negative, and from here to here, the derivative is positive. So I'm looking for something that's going to be below the x-axis, then above the x-axis. This is always above, so that's off. This is always above, so that's off. This one crosses once, so that's a possibility. This crosses twice, not a possibility. So these are my two candidates. So let's think about it. Somebody describe for me the slope right there. Very close to zero, but still negative, right? So I want to see something that is just barely below the x-axis. This is a ways below the x-axis. This is close to the x-axis. Somebody describe for me the slope right here. Very close to zero, but positive. No, it's very close to zero, but positive, whereas this is way above. You tell me when the slope is most positive. Right there? Right about there? So if you see, look, this one is most positive about 3/4 of the way through. See what I'm saying? So D is the only answer. The only other reasonable answer is C, but that's not correct. Okay, this one kind of tough. Okay, this is, I can see where it's challenging. You might take a guess on this one, say I'm going to move on to something else I can find. Totally get it. I'm going to help you make sense of it pretty quickly. In order for a function to be continuous, would you agree that the output from the left has to be the same as the output from the right? So if I check the left-hand side, that better match with the right-hand side. If they're off, then it's discontinuous. So I'm going to plug in 1, and when I do, I get, when I plug in 1 there, I get a coordinate of 1. I get an output of 1. Everybody see that? And then when I plug in 1 for the bottom here, I get 3 times 1 is 3 minus 2 is 1. And the natural log of 1 is 0. So notice how they built in a situation where you have to understand logarithms without being able to type it into your calculator. Good job on the AP for checking that out. So, do they meet together? They do not. So it is not, so you can't say this. The limit from the left is not the same as the limit from the right. Okay? That is definitely not an option. If it's not continuous, is it differentiable at that spot? Absolutely not. So, we know that 2 is the only option if it works. So we need to check that this one says the derivative from the left, and this one says the derivative from the right. Somebody tell me, what's the derivative from the left? 3. Everybody see that? Now I'm going to check the derivative from the right. I have the natural log of u, and I have 3x minus 2. Derivative natural log of u is 1 over u, and derivative 3x minus 2 is 3. So I multiply them together, I get 3 over 3x minus 2. And so I'm going to find the value of the derivative at 1. I plug it in. I get 3 times 1 is 3 minus 2 is 1. I get 3 over 1 is 3. So this does work. 2 only. Okay. Raise your hand if you would get to that problem. You're just like, I'm just taking the loss right now. I'm just moving on. I'm guessing. Folks, there's nothing wrong with that. Remember, you get 50% on this test, and you're doing pretty well. Can everybody appreciate the level of understanding it takes to really see that problem all the way through? Understanding piecewise functions, understanding the original function, understanding continuity, understanding differentiability. So you can see the high-level question that is. So I love the question, but yeah, I'd encourage you guys to skip it. Function of f is defined by this. I would encourage you not to skip this. The application of the mean value theorem to f on the interval 1 to 3 guarantees the existence value c where 1 to c to 3 such that f prime of c is equal to. Can somebody tell me the mean value theorem? F of b minus f of a over b minus a is equal to f prime of c. So all it's asking you to do is find f prime of c. F prime of c is equal to that, which is simply slope, average rate of change. That's all they're asking you to do. So what I want to do is I want to plug in 3. So I'm going to do f of 3 minus f of 1 divided by 3 minus 1. That's all I'm asked to do there. That's it. So I plug in 3, and I get 3 cubed is 27 times 2 is 54. Minus, I plugged in 3, so 3 cubed is 27. Then 3 squared is 9 times 4 is 36, plus 1. So 54 minus 36 is 18, plus 1 is 19. Minus, now I'm going to plug in 1. If I plug in 1, I get 2 minus 4 is negative 2, plus 1 is negative 1. And we divide that by 2. So I get 20 over 2, which is 10.
I knew the number, I forgot. I did that. I was really trying to remember what.
How we doing? It's okay. It's all right. It's tough stuff. If it was easy, everybody would be taking this class. Trust me. Shh. Okay. When I first looked at the problem, this next problem, I immediately tried to classify it as a related rates of change problem, but it's not. Let's see what's happening. Velocity in meters per second, a certain type of wave is given by this. So, are we given the velocity function, the position function, or the acceleration function? Which one? You're given velocity, where h is depth in meters and water through which the wave moves. What is the rate of change in meters per second per meter? So meters per second per meter, okay? So what is it asking for? It's asking for the derivative, isn't it? Okay? It's asking for the derivative of the velocity of the wave with respect to the depth of the water when the depth is 2. So all it's asking for in this situation is the derivative at 2. So it's checking to make sure that you understand that that label is that, okay? So here we go. All right, so let's take the derivative. V prime of h is equal to, should have 3 over 2 roots of h. And we're going to go ahead and plug in 2. And so you get 3 over 2 roots of 2. Okay. All right, flip it over. Oh, are we already there? All right, Kathleen is skating. Good for Kathleen. Use the data in your table to estimate Kathleen's acceleration. Well, this is velocity, isn't it? How do we come up with the acceleration? Derivative. We can't take a derivative really, so it says estimate. We're going to use rate of change using slope, so we're going to use those two. So we have simply k of 5 minus k of 3 divided by 5 minus 3. We had 10 minus 5 over 5 minus 3, and we get 5 over 2. What is our label? Feet per second squared. Yep, feet per second is the velocity. The acceleration is feet per second squared. The units of measurement will probably be a point on that. We'll check. Use the right Riemann sum with 4 subintervals to approximate that. Excellent. I will say that the integral 0 to 12. And when I've seen this, I'm like, yay, they're asking me problems I know how to do. That's equal to, can somebody tell me the first width? 3 times the first height plus 2 times 10 plus 3 times 20 plus, okay, well, I've got 15 plus 20 plus 60 plus 96. So I've got 80, I got 95 plus 96, and that's 191. And if I'm determining that, okay, that would be the total number of feet I've traveled. So.
It's not per second.
No.
Once I do a label, I do the label wrong.
So just to be clear, if you're given velocity, if you take the derivative, you're moving towards acceleration. So it'll be feet per second squared. If you're doing the antiderivative, that brings you to position. So you're just feet. So integral backwards. Velocity, feet per second. So if you're doing the antiderivative, you're going to get here. If you're doing the derivative, you get here. This was an antiderivative operation. Okay, overestimate or underestimate? Talk for 30 seconds. Try to decide. Go. And everybody back here, let's watch, okay? Let's look at a couple different functions, okay? This function is increasing. This function is decreasing. Let's look at this estimation. If I do a right hand, am I over or underestimating there? Over. Whereas in this situation, am I over or under? So in this situation, you are overestimating because K of t is increasing. We didn't talk about that a whole lot. I was just waiting for it to come up within an AP sample problem. You'll probably see something like that on the test at some point. It is, how do we know it's increasing? Just look at the values. They're always getting bigger, right? It's plain to see this is on its way up, right? Good. We're almost there. We got 2 left. It says Nathan. Where did Nathan come from? He's just looking for a prom date. He skates on the same track, starting 5 feet ahead of Kathleen. I want to make sure where Kathleen started, so I went back and checked the problem. She starts at the starting line, right? So she starts at the line, and Nathan's velocity in feet per second is given by this thing. They're using n for Nathan, right? But don't evaluate an expression involving an integral that gives Nathan's distance from the starting line at time is equal to 12. And I'm worried the different thoughts we're going to get on this, and so I'm open to your ideas. But distance is going to be equal to his start plus the displacement, which is going to be 0 to 12 of n of t dt. Now, did anybody put anything different? What'd you put?
I put the 0 to 12 n of t plus 5.
You put the plus 5 before the dt. Be incorrect. Did anybody use the absolute value? Okay. So, in this situation, okay, we're going from 0 to 12. I want everybody to think of this for a second. We're going 0 to 12. Will this be positive or negative if you're going 0 to 12? This will be positive, and then e to any power is always positive. However, it's minus 50, 50 times that. I think that this is always positive, so I think that the absolute value expression ends up being fine, but they don't attach an absolute value expression. And what I don't like about the problem is this, is I believe that as it sets up, she's starting here, and Nathan is starting 5 feet ahead, right? So I think he's just, headed out in this direction. They say a track, don't they? It almost gives this idea that you're headed around, doesn't it? We don't know the distance around. So you could make this a lot. Oh, it does say straight track. Oh, okay. Thank you. So if it's a straight track, then we could assume that they're always headed in that direction. So therefore, you do not need the absolute value. You really don't. So because this is always positive, I believe that they would allow that. But if it was ever negative, then that technically wouldn't work. Yes.
I thought that the absolute value was only where they were like total distance and not complete.
I can't really speak to that in that presence of this time. This phrase distance here kind of leads us to want to attach that absolute value. I would say to reserve, I would say your explanation would be pretty good. If they're asking for total distance, attach the absolute value. If they're not, you're probably much more likely to be able to leave it off. In this way, I would encourage, if you put it on, give yourself credit, but I would encourage you to leave it off in that situation future. All right, write an expression for Nathan's acceleration in terms of t. Great. Nathan's acceleration. Acceleration at time t is equal to the derivative of n. Agreed? All right, so I have to take the derivative of 150 over t plus 3. How? T plus 3 to the negative 1 power. Very good. So you get negative 150 over t plus 3 quantity squared, don't you? So if you set up the chain rule there, you're going to come up with that. So we've got negative 150 over t plus 3 quantity squared. And then we have to do the negative 50 e to the negative t. So negative 50 e, it's e to the u. You have negative t here. The derivative of negative t is negative 1. And then you have negative 50 e to the u. So we multiply them, those cancel. So it's a plus 50 e to the negative t. That is the derivative. All right, let's check the scoring guide, see how you did. Okay, the scoring guide. If you came up with 5 over 2, you get a point. Yeah. If you came up with the feet per second squared, you get a point. If you came up with the 191, if you showed the work for the Riemann sum, so that you were doing width times the height, showing that was the correct right Riemann sum, you get a point. If you actually then came up with the right answer with the right unit, you had to get 191 feet.
Are you kidding?
It said indicate units of measurement.
So then I can't get that even though I got the number.
Hey, I've been there before. It's a tough deal. I feel your pain. Sorry. And then the reasoning of the overestimation. So you have to say overestimation because it's increasing. That gives you a point as well.
I get like half these. I say overestimate, but I don't explain.
If you had position is equal to, notice how they use S of 12. I like that. I would encourage you to use that. If you just say position, I think they'll give you the answer anyway. 5 plus the integral 0 to 12 of n of t dt. And then, so that's 1 for the integral. And then it says 1 for the answer. What? I don't get it. I guess 2 points for the integral. I don't quite understand. So my guess is that they give you 1 point for the integral and 1 point for the use of the 5. That's my guess. And then letter D here, it looks like they give 2 points for coming up with the correct derivative, which is negative 150 over t plus 3 quantity squared plus 50 e to the negative t. Please flip it to the front of your work. Okay, so you got multiple choice. You got free response. Okay, how many multiple choice problems were there here? There were 10. So write how many you got out of 10. And then the free response, there was a total of 9. Right? How many you got out of 9? Explanation took a little bit longer today. Yes. S of 12 is how they write it. S is indicating position. So I do like that notation. But if you didn't have it, I don't think that that's a problem.